Hi everyone, welcome to this tutorial on R, and this is for beginners. Let's see what is R programming and how it helps. So R is well known as a language of data science. Now if you really look at the ranking from survey of data mining experts based on the softwares they have often used in their work, R is used more than Python when it comes to data science. Python is also used, however R is predominantly more used for data science kind of activities. It's a open source programming language used for statistical computing. It is one of the most popular programming languages today. It was inspired by S+, and it is similar to S programming language. So when it comes to data science, what we can say is R is a popularly used programming language across the globe. It is free and open source, as I mentioned. It is optimized for vector operations, which we will learn about later. It has an amazing community, has in fact 9,000 plus contributed or community packages, allowing us to do almost anything or everything using R. Now, when we talk about features of R, as I said, it's open source programming language. So you can install R for free and you can straight away start working. You wouldn't have to really go for a licensed version or pay for the software. Non-coders can also understand and perform programming in R as it is easy to understand, and it has various data structures and operators. It can be integrated with other programming languages like C, C++, Java, and Python. It consists of various inbuilt packages, a lot of sample data sets which can be used, and that makes reporting the results of an analysis easier by using R. Now, before we start learning about variables, loops, how you work with R, and so on, it would be good to know how you can set up R and work on R. So for that, what you can do is you can just go to r-project.org, and once we get to the home page of our project for statistical computing using this link, we can click on download R here. Now that brings you to a page to download it. Now there are various links here. So it shows you the comprehensive R archive network, that is CRAN mirrors, and it is available at different URLs. However, I would choose the first one, which is Zero Cloud. You can just click on this one, and then based on your operating system, whether you are working on a Linux machine, on a MacBook, or Windows, you can install it. So you can just click on this one. As of now, I'm using a Windows machine, so I can click on download R for Windows, and that takes me to this link which says binaries for base distribution. Now this is what we can use to work with R straight away. However, there is one more package, that is RStudio. We will see how we can set up that. Now this one takes us to the best mirror possible for our location from where we can download R. So you can click on this base and then you can download by clicking on this link. I have already downloaded this. So once you click on this one, you can just save it. So I have it here already in my downloads, and that's more than enough. Then you can just double click and you can go through the instructions to set up R. That would also allow you to basically set up a desktop shortcut, which I have already done here on my machine. And if I go in here, I see R base. You can click on this one, and that brings you to the page which you can use to straight away start working with R. Now, yes, there is one more package called RStudio, which is set up on top of base R, which makes working with R easier. Now, here also you can start working. So it shows you R console, and you can click on file. And if you have some scripts or files already written in the format of R, you can use those. So I can click on open script, and that takes me to a page where I have some files which are already existing. I can just select this one and click on open, and that shows me some options here. So I have an editor which shows me, say, if I want to get a library to use built-in data sets, I could summarize the data, I could do a cleanup, and we'll see all of this. But I would suggest using RStudio rather than just using base R. However, installing base R would be required. And depending on your machine configuration, like mine is a 64-bit, I have chosen 64-bit while I was setting up base R. Now, when it comes to RStudio, it is basically a package which makes working with R easier. So to install RStudio, what you can do is you can go to the RStudio homepage, or you can just go to Google and say type RStudio download, and then it takes you to this page. You can click on this which says download RStudio. You can choose your version. You can go for the free version, that is RStudio desktop, and you can click on this download, and then you can download RStudio for Windows, which I have already done, and then you have to run through the steps. So just click on this one, and I already have RStudio here. Right now I can just basically use that. So for example, if I go to downloads and if I look for RStudio, if I do a double click, I can say yes, and then it takes me to the RStudio setup. Just click on next, and here you can choose the location. If you would want to place it in a specific location, click on next, and then it says select the start menu folder. So let RStudio be chosen here, click on install, and then it will basically start installing this in a particular location. Now in my case it is already existing, right? So we can even click on show details and see what it is doing, what packages or what executables it is extracting. Now once this is done, then you will be able to use RStudio. You can also add a shortcut to your taskbar and you can continue using it. So I've already done this. This might take a couple of seconds. Just wait for this to complete and you would have RStudio, which is an easier way of working with R. So a lot of developers across the globe would be using RStudio when they are working with R to work on their data science or programming requirements. Now let's just wait. It is almost done. And now I can click on finish. So that part is done. You can add it as a shortcut. So RStudio has consistent commands. It has unified interface. It makes easy to navigate and manage through R, and it is set up on top of your R base. Now if I click and open on this, so that's my RStudio which is coming up. Now here you see console, which will show you the result where you can give your commands. So where we can get text output. Now again, I can choose a file. So I can just say open file, and then I can go into a particular location where I have downloaded some data, and then basically I can choose, say for example, RStudio, and that brings me here. So now you have your script which has some commands, right? On the left bottom you have console where you can see the output. On the right side you also have environment. Now that is to use or provide variables, and then we can also have plots which we can see here. Now we can look at this as an example. So here I am loading the built-in data sets. So what I can just do is I can place my cursor here and I can just do a control enter, and that basically loads the built-in data sets which we can see here. That has been done. Now there is an inbuilt iris data set, and we can just use head option to look at the first 6 lines of iris data set. So just place your cursor and do a control enter, and that shows you a summary, basically the first 6 lines of this data set, what it contains. We will look into this data set later. This is a default data set which you can easily find when you're working with R. You can also have your cursor placed on summary and then just do a control enter. So that basically shows you summary statistics for iris data. You can do a plot, and that basically shows you the plot, which you can also maximize and look at it in full screen. You can just do a zoom if you are interested in looking into this, and we will discuss how or what kind of information we can infer from the plots. Now when it comes to cleaning up, you can just do detach, and then we can say package data sets, and here we had loaded those data sets, so we are just doing a detach, and we can say unload equals true. So I'll just do a control enter. I can also clear off the plots by doing this for whatever plots we had, and we can either do a edit and then we can do a clear console from here, or the shortcut is control R and you can clear off the console. So that's a simple way of starting your working with R by installing R Studio. So let's continue learning about working with R. And basically the first thing which we should learn here is about variables in R. So variables, as in any programming language, is a way to store your data value, factor of list values, or a data set or object in R. It allows us to conveniently reference the variable name, basically saving us from rewriting the data value or object many times in our program. So when we talk about variables in R, they are mainly used to store data with named locations that your programs can manipulate. A variable can be a combination of letters, digits, period, and underscore. So you can have some valid variables as total, sum. You can also have dot notation. So there are different naming or style conventions in R, and we can use dot to separate names in description of a variable. We can also start a variable with dot. We can include numbers in a variable, and remember, R is case sensitive, so we have to, whenever we declare a variable, we need to remember what case was used, as in the name of the variable. And there can be other conventions also, such as using an underscore or even using a case in between the variables. So variables can only consist of letters, numbers, periods, underscores, your dot followed by a letter, not a number. And we can declare our variables. We can also look at the type of the variables and the class to which it belongs. So there are some invalid variables which we are seeing here, so that also needs to be remembered. So this is an example where you can use an assignment operator, which you see here between x and 10, to assign a value to a variable. You could also do that by doing a dot y and then assign a value. You could be doing that by using a z and then having a computation done between x and y, and finally you could do a print. So let's see some example here before we move further, and for that I can bring up my RStudio here. So as I said, we can basically have different kind of variables or naming conventions. For example, I could do something like model 1, and then I can basically assign this. So this is just a variable, and I could be assigning anything to it. I could be assigning different data types which are available here. For example, I could do something like this, and I could do a control enter. So that's my variable. I can always do a type of, and then basically I can check what is the type of my variable. So it tells it's a character. I can also do a class, and then I can basically say show me the class, and that shows me it belongs to the character class. We'll learn about data types later, but we are using an assignment operator now. If I say what is model 1, it shows me the value, but if I would do something like this, then it says object model not found. And why? Because it is case sensitive. The variable which we had created was all in lowercase, and the one which we tried to call was starting with an uppercase. So you could have variables created in such way. I could also do something like hello underscore string, and this could be my variable where we are using an underscore, and then we can just give in something here, and that becomes my variable which you can always call, and check what is the value of that. You could also be doing something like this. So you could be using different cases, and then I could say something like this, and that's also my variable. And then I can basically look at the value of this variable. Now, if we try to create a variable where we start the variable name with a number, what would happen? So if I say something like this, and then if I try to assign a value to it, for example, let's say 100. Now this one will throw an error message because you cannot have your variable starting with a number. But if I used period and then basically give something like this, and let's try doing this by giving it a number. So if you see here, since we gave a period, the rule is that it should be followed always by a letter and not a number. So I could just remove this, and that works perfectly fine. So these are some naming conventions which when you practice you will learn about. So now I can assign a variable by just doing a dot pairs and then assign any value to it. But always remember, if you are using a period, if you are using a notation, then in that case that should always be followed by a letter. One more thing which is always practiced in a real-time environment is that we cannot have spaces when we are creating variables. So for example, if I say first num and then I try to assign this a value, it basically fails. But obviously I could have done this by doing an underscore, and that perfectly works fine, and you can basically then call the value for this one. Always remember, one more standard practice which is followed in real-time environment is you will try to have variable names with a little meaning to them. So for example, if I would create a variable and I would say, for example, let's say bird, that's my variable name. And then if I assign this a value tiger, it works fine, but then it really does not make sense. And that would basically create a lot of ambiguity in our coding. So it is always good to say, for example, animal, and then I would say, okay, so tiger is an animal, and that basically not only allows me to assign a value to the variable, but it is also a little bit more meaningful. Now, when we talk about variables, it is also good to know the different data types which are available in R. Now, like any other programming language, R also supports different data types. So you have your logical data types such as true and false. You have numeric values, which is say these numbers. You could also be creating an integer, which is 3L and 40L, 4L, and so on. You can have a complex number. You can have characters, which can be just letters or a set of letters or anything which is within the quotes, or you can even have raw data. So these are different data types. We can again see quick examples here on data types. Let me come out of this one. And as we saw already, when we created model 1, this was character. Now I can just say X and let's say 100, and obviously this is going to be not my integer. Okay, so let's see this. What is this one? This one by default is double. It is by default double. So if I would want an integer, then I would say, for example, something like this. And this one you can check by using type of, and you can see the value for this one. So this is an integer. So similarly, you can have character, you can have complex, you can have raw data, you can have numeric values. So all these are different data types. You could also be saying, for example, I would want to check the boolean, so I could check this and select this one, and now when I check the value for a, it is true. And we will learn about logical operators, where we can basically be using these values assigned to the variables to compare, to compute between different variables. So this is a simple small example of using variables. So we have seen here using variables and also using the assignment operator, and then assigning values to the variables and different naming conventions. We can also be using different data types which R supports, and work with the variables. Now, once we have learned about variables or data types, let's also just first learn about your operators and how they can be used in your R programming language. Now, we might be intending to do some calculations on numeric values, find out differences between values, or say, for example, compare values. So in that, we can be using different kind of operators. So we have various operators. We have arithmetic operators, we have rational operators, we also have logical operators. So before we straight away look into logical operators, let's also understand about the basics, such as your arithmetic operators, which supports, for example, let me pull up a notepad file here. And when we talk about arithmetic operators here, we are talking about your addition, you have subtraction, you have multiplication, you have division, and you have remainder or modulus, and you have exponent. And what makes it also important is that when you're using arithmetic operators, you also need to know about the order of operations. So when you say order of operations, always the priority is to parenthesis. So that takes the priority. You have then exponent or your computation if that would involve exponent. So let's say exponent here, which is then followed by your multiplication and division. And that one also follows an order of left to right, whichever comes first when we talk about multiplication and division. And similarly, when we talk about addition and subtraction, it is left to right, whichever comes first. So these are some of the arithmetic operators. Now we can see some examples here quickly, although these are some simple examples. So for example, I can say 100 plus 100, and that gives me the value, right? You can always do 100 minus 50. You can do 100 multiplication. You could do 100 division too, or you could also use modulus 2, which basically gives you an error here. So I will, oh, just give me a minute. So let's give here one more percentage sign, and that basically says what would be the remainder. So if we would want to look at the ordering when we are using this arithmetic operators, we can see an example. So for example, if I say 34 plus 46 divided by 2 gives me 57. However, if I use 34 plus 46 in parentheses, which gets the priority, and then I divide, my result is different. So understanding what arithmetic operators you can use, and also the ordering in which that leads to the computation, is very important. So we can use all of these arithmetic operators, and to control the ordering, we can be using parentheses, or we can have our computations ordered with what kind of operation we would want, whether that would be multiplication or division, addition, or subtraction. Now at any point of time, I can always do a control L, and that allows me to clear my console. Let's continue our learning and let's learn about operators. So when we speak about arithmetic operators, we see that allows us to do computations, but we have also rational and logical operators which help us in doing our computations or comparing values or sometimes finding difference between different values, whether those are group of values or whether those are individual values. So with your rational and logical operators, you can compare data values. So if we would want to see if the values match or not match, or if the values are above or below, equal to something, and so on. So when we talk about your rational operators, we basically have, in case of rational or logical operators, rational or logical operators. So we obviously have greater than, you have less than, you have greater than or equal, you have less than or equal, you have equal to, and you have not equal. These are some of your rational operators, we can say. And when you talk about your logical operators, then you have and, you have or, and you have not. So and is when it compares two values. So it returns true if both the conditions are true, else it will return a false. So for example, if I have 10 greater than 20 and 10 is less than 20, now that's not possible. And we are comparing the result of both of these. So we are checking if both the conditions are true, and that's not really true here. So we see the value as false. Now, if I would have replaced this and with or, it would check even if one of the conditions is true, it would basically show me a result as true. You can also use a not operator, which takes each element of the vector and gives the opposite value. So we can be using any one of these operators and then basically do our computations. So let's see some examples about these logical operators. Now either you could just be assigning values to your variables and check, or you could also be picking up a data set from your machine and then try to use these logical operators. So for example, if I say X has been assigned 100, Y has been assigned 200, and if I try to say X equals Y, so that already checks the value and compares and tells me that's not true, it is false. And if I would have used a not operator, for example, if I would have said something like this one, so it tells me true. So I can just check simple conditions like this. I can say, is my Y greater than X? And that tells me yes, it is true. If I say Y is greater than or equal to X, well, it would still say true, because when you are saying greater than or equal to X, so when you're saying this one, it works fine, right? Now we can also be picking up some data set, and for that what I can do is I can pick up one of the data set from my machine. So I can go in here and I have some data sets. Let's look into that. And I would be interested in taking this auction data set and loading the values here. So I'll get this path and I will come here. I can use auction as my variable name. You could have given a dot separated name. For example, I could have said auction dot data if this is what you want to do, and then you can assign variable a value. So here I'll say read.csv, and I intend to pick up a file, so I give this path. And when we are working on Windows machine, we need to give a double slash. So I'll say auction.csv. Now I could give other things like header being true, what is the separator. If you would want to fill values to take care of missing values, we can look at all of those. So here I'll just add a backslash. I will add a backslash, and I will basically just do a control enter. Now I can look at the values of this by just doing a auction.data, and I can see what values it has. So it has a lot of data here. It has a lot of your data here. You could have used some other functions which we can see later, where I can choose head and I can see the first top 5 values. So we can basically assign data to the variable and continue working on this. Now we can keep it simple. So let me repeat this step, and here I will say auction as my variable name, and I'll assign this. So I can basically do also a view on auction. So auction, and then basically that shows me a tabular format of the data, which allows me to look into the data and basically understand it, and then I can use this to work on variables. So what I can do here is I can say X, and let's say assign some value to this, for which I would want to work on my data set, which is auction. Now what do I want to do here? So let's use auction, and then I can use a dollar symbol, and I can choose which column I'm interested in. So for example, let's choose bidder, and I can just give a value to this one, and let's pick up a name. So let's say tweak, and that's the name. And I can be assigning all the values to this, or I could say I would want to use another condition. So I'll say auction dollar, and then let's take this value of bid, and let's say it is equals to 100, and then I ended up with comma, and I can try doing this. Now here it gives me a problem, because what we did was we did not use the right operator. So we will say, for example, and. So I will say X is being assigned the value of auction bidder being tweak, and auction bid value being 100. So now once we do this, I can look at the value of X, and that shows me the value. So this is just a simple example of using a logical operator. Now I could have just said, instead of and, I could have used or, which is basically a pipe which you have to use, and that gives you or condition. And now hit on enter, and if I now look at the values of X, it will show me a lot of values, because we have given an or condition which basically matches one of the conditions. So in this way we can use logical operators and continue working and continue doing our computations. Let's learn about print formatting and how print can be used to view your data. Now, when you talk about R uses print function to display the variables. So for example, if I have assigned number 10 to X, I can do a print X, and that will show me the value of X. What we see here with 1 in square brackets, that also has a meaning, which basically means it is a vector, and we'll learn about vectors later. So R uses the paste and paste zero functions to format strings and variables together for printing in few different ways. For example, if I would do this, which I say is print paste, and then pass in two strings here or two words here, such as hello and world, that would be printed as follows. Now I could also do a print paste and then use a separator. So my print would look something like this. If I use paste 0, then that avoids any space between these two words, or for example, these three words. So let's see some basic examples here when we talk about print. So for example, if I bring up my R Studio, here is an example. So X, as we say, now this is your assignment operator, which we already discussed. Now I can be assigning a value to this. So I can just place my cursor here and I can just hit on Control Enter. So value has been assigned. Now let's look at the value of X. Now I could also be doing a print X explicitly by using print function. For example, if I do similarly for message as hello, and then I can print the message by using print. Now, if for example, I do something like this is not going to print anything until I call the variable or I use a print function. So for example, if I do a Y, we see auto printing shows us the value, or I could do explicitly by using the print function by explicit printing. Now whenever we look at this number 1, as I mentioned, it means Y is a vector and 5 is its first element. Now you can also use operator to create integer sequences, and we'll learn about sequences or list later, but this is just a simple example. So I am creating an integer sequence of length 20. I can place my cursor here, which would start with 10 and end at 30. So let's look at this values for our sequence of integers. Now at any point of time, you can always use a class to look at the class of say X, and that shows me the classes of integers. Now looking further, when we talk about different data types, as we learned few minutes before, so R has basically 5 basic or atomic classes of objects. So you have character, numeric values, that is real numbers, you have integers, you have complex, and you have logical values. Let's spend some time in understanding some basic arithmetic operations and how you can do it using your R programming language. Now here I've opened up R Studio, and these are some basic examples such as performing arithmetic operations. Now for example, we can add two numbers, and I can just place my cursor here and press Control Enter. That shows me the addition. I can do a subtraction, I can do multiplication, division, also going for exponential power, or use modulo, which returns the remainder. Now, when we are performing operations, what we can also do is we can change the order of operations. And in this case, we are using parentheses. So I am putting in 500 into 2 in a parenthesis plus 80 divided by 2. So first it operates what is given in parenthesis, and that's why I get a result 1040. Similarly, I can change the order of operations. So here I can give 500 into and then something in the parenthesis, so that gets operated first, and hence you get result of 1500. Now we have already discussed about the assignment operator, and what we can do here is we can assign variables some value. So for example, I create a variable called selling, and then I would assign it a value. Similarly for cost, and then we can do some calculation. So we can say profit is selling minus cost. We can do that, and here I can look at the value of profit, which shows me 250. Now let's also spend some time in understanding data types in R. So we can have different types of data. So this one shows me an example of assigning a decimal value, which is part of a numeric class. So I can do this, and then if I would be interested in seeing the value of num, so I can just look at the value of num. If I would be interested in looking at the type of num, so I can do that here by just typing in type of, and then select this one and pass in your num, and it shows me the value is double. I can also look at what class it belongs to, and that shows me it is numeric. So in this way, you can not only assign values to a variable, but you can look at the class and type of it. Now here we can assign whole numbers, which are also known as integers. Now if I look at the type of this, it shows me double. So if I would want to explicitly assign an integer, I could have done, for example, let's say j, and I could have used the assignment operator, and I could have done this. And then if I look at the value of j, it shows me the value. But what we would be interested in looking at the class of j, so we can do this and it shows me it is an integer. So explicitly, either I can assign this by using a capital L, or I could use a function called as.integer. So we'll see that later. Now we can also assign Boolean values, or basically your logicals. So here we assign true and then we do a false, and we can look at the type of T, and that tells me it is a logical class. Now, similarly, you might be interested in working on text or string values. And here we can do this by saying ch and then passing in a value. Look at the class of this. It tells me it is, the data type is character. And if you look at the type of it, it says me character. Similarly, R also supports complex data types. So we can do that too by just doing this and look at the class of it. It tells me it is complex, and you can also pull out the length of this by, now here we are doing a length on the character. So let's look at this one, and it shows me what is the length of this. Now, one of the useful functions which we usually use in R is print. Now I can simply do a print hey, and that prints whatever value is passed to print. I can assign a value to a variable and then print it. So that is also fine. You could have also, without using function, just typed y, and that also shows the value. However, sometimes using print as an explicit function can be useful. It makes your code more readable. Now here we would use an inbuilt data set, that is empty cars, and then if you would want to print the data set, that shows me the values, which shows me the car models and different other features such as mileage, cylinder, horsepower, and so on. Now, one of the use case of print with a paste function can also be seen here. So I'm doing a print paste, and that basically prints whatever was passed in a concatenated way. I could also do a print paste with a separator if I would want to format my data in a particular way. So here I've used separator as comma. There is one more function, paste 0, which can be used. So I'm doing here paste 0, and that tells me just concatenate these values without any space. So paste 0 shows no space between these two elements which were passed. Now we can explicitly do some printing, and for that I'm using a sprintf option. I am going to pass in %s, which is for string, and %f for float, and we can print the values of this. So these are some basic operations or usage of your functions to basically do some computations or look at your results. So when you talk about basic type of any R object, it is a vector. And when we talk about vectors, empty vectors can be created with vector function. A vector can contain objects of same type or a class. Now when we talk about list is a vector which contains objects of different classes. So these are some basic examples. So apart from your print formatting, we can be looking at what we call as R objects, such as vectors or lists and so on. So when we talk about vectors, it is a sequence of data elements of same basic type. We use the function to declare a vector. So we can always do a C function to declare a vector. For example, here we are creating a variable v1 and we are assigning it a vector by using C and then giving some basic types, so numbers 1 to 5, or for example words. You can always do a print, or you can also use a class to find out what is the class of the elements or the values which have been passed to the particular object. So we can look at some examples like this. For example, we can see here, so list is a vector which contains objects of different classes. So you can have numeric objects, so that is your numbers such as 1, 2, etc., which are your numeric values. For example, here what we are doing is we are assigning a value 1 to A, and that can then be used. I can either do a print or I can just use auto printing. I can also do here a value for AI, or I could be doing something like this, which shows me 0, which can be for missing value. So if I would want to use auto printing, I can just call A and it shows me the value what has been assigned to it. You can always use a type of to look at the value of A, which is double by default. And if I look at type of AI, that is basically an integer because we used L here. So in this way, we can continue working with, say, different classes of objects. So for example, let's create a vector here. So I can say v1 and then basically assign it by using a C function and then pass in the values to this one, and that basically gives me a variable, and you can look at what are the values assigned to it. Now if I look at the class of v1, that shows me it is numeric. If you use type of, and then you would want to see the values of v1, that shows me the values are double. Now as we were seeing here, we can be looking at the class. So for example, if I create one more variable and then assign values to it using C, so passing in some words here. For example, let's go and say hello world, and then I can basically do this and look at the values of this one. I could also explicitly print, as we discussed earlier, by doing a print v2. We could also be having a paste function if we would want to use that. So for example, if I would do a paste function, I could be using, and this is missing a bracket, so let's complete this, and that shows me the value. I could have also used, for example, paste 0 function, and that also works fine. So it depends on what we are looking at here. So if I look at class of v1 which we had, it is numeric, and v2 is basically having elements which are of the class character. So this is just a simple example of having your print functions, having vectors created, printing out the values of those, printing out class and type of these. To continue our learning on vectors, as I mentioned earlier, we can use the C function, which can be used to create vectors of objects by concatenating things together. So for example, if we look at this one which says X, and then I use C function and I say 0.5 and 0.6, so we can have a vector of numeric types. So let's do this, and then we can look at the value of X. So it shows me my vector which has 0.5 and 0.06. I can also have my vector of logical values, and now let's look at the value of X. So it has true and false, or we could have done it in this way where we can then look at the values. So we can use the short form by using capital T and F. I can create a vector with character types and then look at the values of those. I can also be creating a sequence of integers as we saw in previous example, and then look at the values which start at 9 and end at 29. Now you can also create with complex types and look at the values. So these are some simple examples of creating vectors. Now we can also use vector function to initialize vectors. So for example, if I would do this, where I'm saying my vector will be of type numeric, length is 10, and then look at the values. So it just shows me a vector which has all zeros and the length is 10. Now you can create a vector of numbers by doing this, as we saw in previous example, and use explicit printing to look at the values, or might be a letters, and then use a print statement to print function to basically look at the values of the vector. Now we can also try concatenating the above two, so that creates a mixed vector which has two different kind of types here. So I can do a mixed vector by using the C function and then passing in my numbers, which has numeric types, and letters, which has character types. And then we can basically do a printing of this, which shows me the value. But here what we see is coercion. That is basically casting, if you would know as the word in different programming languages. So it basically coerces the numbers to character, as characters cannot be coerced into numbers. And then you can print the values of this mixed vector where everything is of character types. So for example, at this point of time, if I would have done something like class of mixed vector, and if I would want to look into the values of this one, it shows me everything is of character types here. Now data type of different vectors can be returned by the function class, as we saw just now. So it is common to use the class function to interrogate an object asking what is the class. Now we can create one-dimensional objects such as an integer vector, which we have done earlier, and then look at the class of it, which tells me it is an integer. I can also create a numeric vector by giving in some values here. So when we do this, so I have given the vector function C and then giving in the value and look at the class, it shows me it would have numeric values. Now you can create a character vector and then basically look at the values of it. Now at any point of time in all of these, for example, if I would do num, I can see what are the values assigned to it. I can do letters and I can see the values of this. So let me just create some space here. Now I can create a factor vector and then look at the values of it, or also you can see what is the value in this factor vector. So here we said as dot factor, so factor function is being used here, and we are creating a vector of letters, and then we look at the class. We also look at the values what are assigned to this or what are in this particular vector. So if you look into all of these vector examples, initially we were using an assignment operator where we were using the C function, and when we started creating vectors by say concatenating or vectors of particular types, we are using equals here, and that also is fine. Now looking further, when we look at concatenating two different kind of vectors, so for example here we have say numbers and letters, as we discussed earlier, it will do coercion, that is change one type into other. Now when we talk about one-dimensional objects, we can have integer vectors or say float, which we saw just now, ending at 10.5. So when we say C 1 is to 10, it basically starts with 1, but then there is also, you can say, a coercion happening here, and then you have the values ending at 10.5, that is float, and I can look at the class of it. And when we did a class of Did we do a class? Yeah. So let's come here and let's do a class of this one. It says me it is numeric. You can look at the values of it. Similarly, you can create a character vector which is 1 to 10 and then basically look at the class of it, or basically the value of this vector, or as we did the factor vector. Now for two dimensionals, we will explore that when we are learning about matrix. So as of now, let's forget that. Now when you talk about mixing objects, there are occasions when classes of R objects get mixed together. So that could be accidentally or that could be intentional. So if you look at this example here, we have Y, which has been given values which is 1.7 and A. And at this stage, if I would look at the value of Y, that's my vector. If you look at the class of Y, that shows me it is as character. Now when you look at some other examples, so let's pass in logical and numeric values. What would happen in this case? So we can again use class of Y, and that basically has numeric. And if you would want to look at the value of Y, that shows me 1 and 2 here. Let's go further. So let's look at the value of this one. So Y, and then basically see what is the value of Y. So it is A, true. And you can also look at the class of it. Now we are mixing objects of two different classes in a vector. Remember, when we talk about vector, we always talk about vector having elements of same type. But when we talk about lists, which we will learn later, that would have basically, or that can have your each element of different type. So for vectors, it is not allowed. So when different objects are mixed in a vector, coercion occurs so that every element in the vector is of the same class. Now, we have seen earlier the implicit coercion, where R tries to find a way to represent all the objects or elements, as I say, so all the objects in the vector in a reasonable fashion. So we can also be doing explicit coercion, so that is from one class to another by using a as dot and then using a relevant function. So if I have X here, now if I look at the class of X, it tells me it is an integer, but I can convert that to numeric by doing a as dot numeric or as dot logical or as dot character to basically do a coercion and change the class of the objects. Now, if R cannot figure out how to coerce an object, this will result in NAs being produced, which we can also relate to missing values or not applicable values. So for example, if we create X and look at the class of X, it tells me it is character. Let's try changing character to numeric, which will not work. And it says NAs are introduced. If you do it even in logical, that would not work, and it shows me NA values, or if you do a complex, it says values have been introduced. So at this point of time, if I look at the value of X, it tells me it was assigned ABC, and we try to convert that into a different class. Now, when we talk about vectors, it is also good to know about attributes in brief. So all your R objects have attributes, that is metadata for object. So when you talk about R object attributes, you could have names, you can have dimension names, you can have the dimensions, that is matrices and arrays. You can look at the classes such as integer, numeric, and so on. And you can also look at length, which is user defined attribute. So if I say X, we are assigning a value to X. Now at this point of time, if I see my value to X is 1, but then all objects need not necessarily have attributes. So in that case, whenever you try to use an attributes function, that would return null. So at this point of time, if I look at the attributes of X, it shows me null value. So these are some of the basics which help us in working with R and using your vector function, or looking at the coercion which is implicitly happening or explicitly can be done by us by using a as dot sum function. Now let's learn about lists and how we can work using R on list. When we talk about vector, which we saw in previous examples, vector is a one-dimensional array, right? And it can hold elements only of same type. So we would say vector is more of one-dimensional. But when you talk about list is a generic vector that can contain objects of different types. So when you talk about, say for example, matrices can also hold elements of same type, but in matrices it is a two-dimensional array. We will talk about matrices also, we will learn. So when you talk about lists, they can contain all kind of R objects. So you can have dates, you can have data frames, you can have vectors, and many more. So in list, there is no coercion which is required, that is changing of data type. There is no loss of functionality, and lists do not follow any predefined structure. Now we can create lists using this list function as it is shown here. So you can create a variable and then assign a list to it, where you can be using either passing in a vector, or what you can do is you can simply create a list by using this list function. So let's see some example here. Now for that, what we can do is I can bring up my R Studio, where we can see an example on list and how it works. So when you talk about list, what you can do here is, let me close this one and this one. Yeah. So what we can do is we can basically say, for example, test, and I can basically give something here. So for example, I can say music tracks, and then I can say how many hundred of them, and I can say, let's give 100 as number, and then we can say how many of them got 5 stars, and I can do this. So I can check this, and this shows me all the objects or elements of this list, right? Now when we do this, what we are doing is we are creating a vector, right? And vector basically can have coercion depending on what are the elements which are passed, because whenever you use the C and you create a vector, it will only accept elements of the same type. So for example, if I do a class on test, it shows me here all the objects are of type character, right? And you can also use type of to check for our test variable, and it is basically having all the objects as character. Now how would you create a list? So what we can do is we can use a list function. So for example, let's again do a test here, but this time I'm interested in creating a list, and list can have objects of different types. So let's say music tracks, and then I can just give 100, and I can say with rating 5. And now if I look at my test, it shows me all the elements of your particular list. Here we see each element or each object with a double bracket, and we can see each element. Now what we can also do is we can use is list function, and then we can pass in test here to check what is it, and it is a list, right? So here we have created a list, but if for example we take the previous example where we were creating a vector, and if I would do a is list, it would show me false, right? So we just created a simple list, and we can also arrange labels, or we can use a name function to basically give names. So what I can do here is, let me create a list first. So I can do that like this. And now what I can do is I can do a name, and I can use a name function to this test. And then basically what I can do is I can pass labels. So here I can just give in some names here. So for example, I can say, let's give it a name, product. So say we are talking about product of a company, and then we can say here I can give count, and here I can give rating, and this is basically to give in names. So let's just give, there's some error here, let me just check this. So let's use this name function here, and what I'll do is I will basically use names, and now let's do a test. So that shows me the names what we have assigned to our list objects. Now we can always access the elements of or objects from a list using indices or even using double square. So for example, I have test here, and basically I can give something like this, which gives me based on the indices the position where you are accessing the elements of the list. So we can do this. What I can also do is we can specify names when creating a particular list. So for example, what I can also do is I can say product dot category, and now I can just give list function. So I would want to assign names while creating a list. So I can say, for example, product, and this would be, say, music tracks. Then I can give, say, for example, count, and count would be 100, and then ratings, and I can say 5, and now we can basically access this list which we have created. So what we have done here, unlike earlier when we created a list and then basically used names function to assign a name to it or each object, here while creating a list itself we passed in the names. So we can also do that. Now if you would want to basically display the list or compactly display structure of a list, we can always use the string function, and here I can pass in the name. So let's choose this one, and this is in a more compact way listing down the elements of your list. So list can be containing other lists also, and we can also do that. So for example, I create one more list. For example, I can say similar product, and here I can give a list again, and what I would want to do is I would want to say product equals, and I can say film, and then I can basically give a count, and then I can give ratings, say 4. And here what I've done is I have just created one more list. But my intention is not just to create a list, but I would want to add this to our existing list. So what we can do here is we can take our previous list, that is product.category, like what we did earlier, and now I intend to say list, and here I would want to say, for example, let's copy this, or we can just, so this is what we were doing when we were creating a list using product, giving the names while creating a list. And what I also want to do is here I will just say similar and then pass in similar dot prod. So now if you look at our list, we have just added new elements. So this is one more way where we can create a list and we can basically add, or our list can have other lists. So when we talk about subsetting or extending list, so one of the main ways, as I said, to access a specific element or a subset, we use double brackets, and we can always do that. So for example, we take our prod dot category, and then I would want to access a particular element. So I can always do this by giving the index positions, and I can access the elements of my list. So this is one single way. Now here, if we use a single bracket instead of double bracket, then in that case, the output would be a list. So if I look at this one, then this would be a list. But if you use double brackets, then you're accessing a particular object. If we were creating a vector, we could just be using a subset by using the C function. Now, what we can also do is we can subset by names or even logicals. So what we can do here is we can take this product category, and if we have defined names, then in that case, what I can do is I can say I would be interested in music tracks, and this is the name we had given. So we can close this one and we can try accessing the elements here. So what's the name we had given? So no, it's not music tracks, that's the value. The name is product. So we do this and then we can access the elements. What we can also do is we can be subsetting based on logicals. So what we can do is we can basically just give something like this, and here we can pass in values. Something like this. And we missed a bracket. So that's also a way of pulling out the values. So you can be doing a subsetting using the names which you have assigned to objects within your list, or you can say names which you have assigned to the elements, or by using logicals. Now what we can also do is we can use the dollar function. Now if you see here, we are looking at the name and that is preceded by dollar. So we can always pull out the values from our list by giving the list name and then give a dollar symbol and then choose the name. For example, if I choose product, I can list the values here. I can be looking at, say, dollar and then choose a count. And this is also one way of accessing your elements from the list using your dollar symbol. Now, to add elements to a list, as I said, you can add a vector of names and that can be passed to your list. So these are different ways in which you can work with list, and then you can access the elements either using indices or using names or even using dollar symbol and pointing the right names. So this is one simple example of working with your list. Now one more, and now I can just do a Control L and I can clear that off. So your list, always remember, is a generic vector that can contain objects of different types. Now when we talk about matrices, now matrix is a collection of data elements arranged in two-dimensional rectangular layout. So we can use matrix function to create a matrix as shown here. So matrix is two-dimensional. Now we already know that vector is one-dimensional array of data elements or a sequence of data elements. But when we talk about matrix, it's a collection of data elements that is two-dimensional, arranged in fixed number of rows and columns. So here you see that we are creating a matrix, and we have specified the number of rows is 3, number of columns is 3, and we want it to be arranged by row where we have given the value as true. So always remember, matrix is two-dimensional, and matrix can have only one atomic vector type, unlike your list. It's a natural extension of vector going from one dimension to two dimensions. So matrix actually needs a vector which contains values that you place in a matrix and at least one matrix dimension. So we can choose to specify the number of rows or number of columns when we are creating matrix. So let's see a quick example of working with matrix. So for example, I could just say matrix which will have values 1 to 6, and then I can basically give n row, and you can give a value to this one, and that's my matrix. Similarly, you could also be giving n columns. So I can just say n col, and I can choose this one and then pass in the value. So that's a matrix where R fills values column by column. Now if you intend to fill up matrix in a row wise fashion so that your values 1, 2 and 3 are in first row, then we have to just modify this in a little bit different way. So we have to say matrix 1:6, and row is 2, and then I can give by row. So you always have these helper functions which allow you to pull out the values. So for example, I do this, and then I can do a control enter. So now if you see, you have the values 1, 2 and 3 in your first row. So when we pass a matrix function to a vector that is too short to fill up an entire matrix, then something different happens. We can have a look at this. So say you pass a vector containing value 1 to 3 to the matrix function, and say explicitly you want a matrix with 2 rows and 3 columns. How do we do that? So for example, I can say matrix, and here I can say 1 is to 3. Now I can give n row, and then I can give the number of rows which we want is 2, and then I say n column, and this one I'll say 3. So I can do this, and here what I have done is I have given the values 1 to 3. I have said number of rows is 2 and your number of columns is 3. So here R fills the matrix column by column and simply repeats the vector. Now if you want to fill using a 4-element vector in a 6-element matrix, in that case obviously R will generate a warning message. Now apart from the simple matrix function which we are seeing, you also have some functions such as rbind and cbind, which are offers when you are working with matrices. So we can use those. So for example, I could say cbind, I could say 1:3, and then I can say 1:3, and that's my cbind, that is column bind, where I'm passing the values 1 to 3 and which are stacked in columns. I can also do rbind, and similarly we can be passing in the values. So I can say rbind, and that basically arranges the values row wise. So be creating a variable, for example, let's say n, and let me create a matrix here. So I'll say matrix. Now that will contain 1 to 6, and I can say by row, and then you can give value which is true, and then I can basically say the number of rows is going to be 2, and this is also fine. So let's look at the value of n here. So you basically created a matrix with 1 to 6. You arrange them row wise, and the number of rows what you have chosen is 2. So what we can also do is we can use rbind and we can add values to it. So for example, if I want to add values 7 to 9, what I can simply do is I can do a R bind. I can say I would want to edit my n and then pass in the values. So I can just do this, and this has basically appended or added values to existing matrix. So similarly, you could have done a column bind and you could have added values to your existing matrix. So for example, if I take this one and look at my n, and what I could do is I could do a C bind, and then I can basically take my n and then pass in values to this one. So let's say 10 and 11, and basically I've added 10 and 11 as a column to my existing matrix. So this is one simple way where you work with a matrix and you are appending the values either at a row level or at a column level. So let's also look at some other examples. So basically, if you would want to work with matrix, one of the useful things would be naming the matrix. That is, in case of matrices, we can assign names to either the columns or the rows. If you don't do it, we see the default values here, which follows a numbering. But what we can also do is we can use two functions here. One is row names, or you can use column names. So these are the two functions which can be used. So for example, let's do a control L. Let's try to get our n, and this is what we are doing here. But what we would want to do is we would want to give them some names. So for example, I'll say row names, and then I will basically pass in a vector which has row names or vector which has column names. So what I can do here is I can say I would want to give row names to n, and then I basically give some value. So for example, let's say row 1, and then let's say row 2, and now I can look at my n, which has the row names assigned to my rows. Similarly, I could have also given column names. So all I need to do here is I need to say column 1, and then I will say column 2, and then I can be using column names. And let's look at this one. So what went wrong here? So we have three columns here. We forgot that. So we have to add one more column name, and then it should be fine. So now if you look at this one, we have just given row names and column names. So naming the columns or rows in your matrices can be very useful. Now, as the previous error says, there is also a function called dim names, and that's basically an argument of matrix function which can be used. So we could also do something like this. So for example, I have dim names. So let's have our n, and then what you can do is you can do a dim names, which you can then just create a list, and in this one you can pass in a vector for row 1 and then vector for row 2. And what we can do here is once we have given this, let's give a comma here and then give C, and then give your column names, which is column 1, column 2, and then basically column 3. And now if you just look at dim names, so you can just see that you have given some row names and column names, and this can be used basically to assign to your list. So if you try to store different objects in a matrix, what would happen? Coercion would take place, right? So for example, if I have X, and let's basically try to create a matrix which will have 1 to 8, and let's say the number of columns is going to be 2. So let's look at our X, and this has the values. Now what if I create, say, L, and then basically I will create a matrix which will be a matrix of letters. So let's say letters, and then here with letters I'll say 1:6. Now I would want to give the number of rows, and let's give it say 4, and let's say number of columns, and let's give it 3. And now let's look at the value of L. So it has letters and X is having numbers. And what if we bind them together using cbind, which is for column wise binding. So for example, if I do a cbind and then pass in my X comma L, so if you see here, there is a coercion which has happened where everything is converted into characters. So you can always do a class and you can check. So this is a simple example of working with matrices. There are much more. You can do subsetting like what we saw in list, but that we can learn later. Now let's learn about data frames and what is a data frame and how do you use R to work with data frame. Now data frame is used to store the data in the form of a table, and for this we have a function data.frame to create a data frame. So what we know already is that data sets are comprised of observations, or what we call as instances or variables, and we always have observations to which some variables are associated. For example, we can talk about data sets of say 5 people. Now let's look at the information here. Here we look at the body mass index BMI, where we are using a data.frame function, and then we are passing in say gender. So we use the C function to pass in the values, and then you have height, and then you have weight and age, and these things then become the columns of your data frame. So for example, if we would want to work on creating a data frame for people where let's say each person is an instance, and properties about each person such as name, age, child, or if the person has a child would become the variables. So if we have such kind of information, we cannot easily store that in matrix or list. Now data frames can be used for such cases. Now, it's a fundamental data structure to store data sets, pretty similar to matrix as it has rows and columns. And here, rows correspond to observations. Now, here we can talk about an every individual or every person. Columns correspond to variables, that is properties for each person. Now, difference between your data frame and matrix is that data frames can contain elements of different data types. So for example, we can have one column being character, other being numeric, and yet another being logical or numeric. So restriction is that elements in one column should be of the same data type. Now, how do we work with data frames? Let's see some examples. So what we can do is we can bring up our R. So when we talk about data frames, usually we don't create data frames by ourselves. We import data from data sources such as CSV file or RDBMS or even your Excel or SPSS, and then we create data frames. Now, of course, R has ways to manually create data frames using data.frame function. So we can create 3 vectors first, and then we can pass in those vectors to create our data frame. So let's do that. So let's say name, and here I will use the assignment operator, which we have learned earlier, and then I'll use C, and then I can give some names here. So let's say John, and let's say Peter, let's say Patrick, and let's say Julie, and let's also give one more name. So let's say Bob. So this is the vector which we are creating, and we can check this is the vector which we have created. Now obviously you can do a class and you can check what is this, and that says it is a vector of character. Now similarly we can create one more vector which is age, and let's give some numbers here. So for example, let's say 28 and 30, 31, 38, 35, and these are the values for the age. So age is also created. Similarly, we can say if each person has children, so we can say children, and then I'll create one more vector, and here I'll give values which are logicals. I'm not going to give any numerics or character, but I'm using logicals here. So if a particular person has children or no. So let's have this vector created. And now we have three vectors, that is name, age, and children. And we can use this to create our data frame. So we can just call our data frame as df. And what we can do is we can use data dot frame function. And then what we can do is we can pass our vectors within this, such as name, age, children, and that should create my data frame. Let's have a look at this, and this shows me that the data frame is created. Now column names are inferred from variables which are passed to data.frame function. So the variables which we have passed to our data.frame function is name, age, and children, and those become the column headings for my data frame. Now what we could have also done is we could have created it in a different way. So I could have said df, and then I could have used my data.frame function, and in data.frame function I could have said name is going to be name, age would be age, and then I could say children could be children, and I could do this. And this is also one more way where I'm creating a data frame, and in this way we can now have rows of data frames like in matrix. So this is also one way of creating a data frame. To look into the data frame structure, we can always use str, and then we can pass our data frame, and this basically prints out similar to that of list. So we also need to know that under the hood data frame is a list, and in this case this is a list with 3 elements. So each list element is a vector of length phi corresponding to the number of observations. If we create data frame with vectors not of same length, we would get an error. Now here, when we look at our data frame, we know that name is a column. So name column, which is character, is actually a factor instead of character. To suppress this behavior, we can always use a property, that is strings as factors equals false. So what I can do is I can do a data frame like this, use my data.frame function, and then basically we can pass in our vectors, that is name, age, and children. And then what I can do is I can say strings as factors and set this value to false. So if I do this, and now if I look at my data frame structure, sorry, yeah, now let's look at this one, and this one shows me that unlike your earlier one, now we are creating a data frame where our name would be containing characters. Earlier also by default it was showing as character. Usually if you, because this value by default is set to false, or it would have created characters or factors as we say. Now how do we do a subset and extend and sort data frames in R? So as we have learned so far in brief about your data frames, so data frame is somewhere like an intersection between matrices and lists. So if you would want to subset a data frame, we can always use the square brackets, and in that we can use the single square brackets which are from matrices, or we can use double square brackets from list, or we can also use the dollar symbol. So that all these things can be used to subset a data frame. So let's use our data frame which contains information about people. So we can select single element from our data frame. So here what we can do is we can just say df, and then I can use a single bracket, and I can just do a 3 comma 2. So it would be good if we can first print the data frame, and that's my value. And now let's do a single bracket, and let's look at this one. So this tells me that we are using the row index first, which is number 3, which shows me that we would be going to the row number 3, and then we point or pass in our column index, that is number 2. So we could have done it in a different way also. So we could have done df and then give a row index and then give the column name which you are interested in looking at, and that also gives me the value. So just like matrices, we can choose to omit one of two indices to end up with entire row or entire column. And for example, if we would be interested in looking for information for Patrick, what I could have done is I could have just done df3 comma, and this is showing me the entire row. Now always remember, whatever results we see here, that is giving me a data frame with a single observation, because there has to be a way to store different data types, and that's why the result is also a data frame. What we can also do is to get entire age column. We can just use our data frame, and then we can pass in the column name here like this, and that gives me just the column. Now here the point to notice is result is a vector because columns contain elements of the same type. In previous example we were seeing a row, and in that row was not a vector, it was a data frame because values were of different data types. Now subsetting a data frame that results in a data frame and contains multiple observations can also be done by doing something like this. For example, I will do df, and then I will say let me get 3 comma 5, and then I can just say age and children, for example. So let's say age and children, and I can be pulling out the values in this way. So I could also be just getting the results in the age column if I'm interested in by just saying df, and here I can just pass in the column number, and that also gives me the age column. Now we know data frame is a list containing vectors of same length. This means we can use list syntax to select elements also. And what we can do is we can use our dollar symbol and then choose the column name. And this is also one way wherein you can pull out the values, or you can use double brackets as I mentioned earlier and pass in the column name. So that's also fine. Or you can give a column number, and that also would work. And in all these cases, result is a vector. Now with single brackets, you can still do it. Always remember, if you use single brackets, then that will result in a data frame. The result can be a data frame here, but what we are seeing here is a list which contains only age column having the data elements. So these are different ways in which you can do a subsetting of a data frame. Now using single brackets or double brackets can have serious consequences. So we need to always think about what we are dealing with and how are we handling it. Now what we can also do is we can extend our data frames. That is, we can add variables, we can add columns, that is adding variables, or we can add rows which are nothing but observations. So adding columns is like adding new elements to the list, and for which we can obviously use dollar or double brackets. Say for example, now this is my data frame, and if we would want to add height whose information is in a vector, so let's say height, let's create a vector here, and this one is what I would want to add for each person. So let me do this and let me pass in some values here. And the last one, something like this. So this is a vector created. Now what I can do is, so our data frame is called df. So we can say df dollar height, and then I will pass in this vector here. And now if I look at my data frame, you see the fourth column has been added, and that's my height column. Now what I can do is, I could have done it in a different way. Basically, if I had my data frame, I could have just done df double brackets and then give it a name, and then I could have passed my vector in this way. However, so this is also one way of doing it. We have already added the column, so we don't need to repeat the step. Now what we can also do is we can use a cbind function. And if you remember cbind, that is for column binding. So for example, let's create a weight vector now, and let's pass in some values here. So for example, let's say 75, 65, 54, 34, 78, and these are my values of weight. Now what I can do is I can just do a cbind and then pass in my data frame and then pass in this vector. And in this way, I'm just adding columns, or I'm extending my data frames by adding more columns to it. Now, obviously, if we can use cbind, then we can also use rbind to add new rows. So for rbind, creating a new vector won't work, because we need to create a new data frame with one single observation. Remember, row will have values of different data types, so we cannot create a vector. We have to create a new data frame, and then we can add it using rbind. So let me create a data frame here. For example, let's call data frame as Tom, and let's pass in some values here. So I will say data.frame function, and then let's give name. What we can do is we can give age, then we can give the logical value, then we can give, say, height, and since we have added weight, let's also add weight. And this is my data frame. Now we can use rbind function. So I can say rbind, and then I can pass in my data frame and this new data frame which we have created. And this tells me that the number of columns of arguments do not match. So we will have to check this one. So we have our data frame which has just height, so it does not have the weight. That was only as the result of cbind. So let's create this Tom again without weight, and now let's do a rbind, and let's again check what is the reason here. So this is height, and let me just check this. So to look at this, this is the error we were getting, because I was creating a data frame with 4 columns, and then I was trying to add that to a data frame which had 3 columns. Now yes, we had done a cbind, and cbind was showing us the 4th or 5th column, but the original data frame only had 3 columns. So what I did here was I did Tom, and then basically I created a data frame with 3 columns which matches with my original data frame which had 3 columns, and then I could use rbind to basically add one more row. So what we did was we used rbind, and rbind was used to add a new row to our data frame. Now, when it comes to sorting or ordering your data frame, say for example, we want to sort data frame by age. Now, how do we do that? So we could easily do sort df and then select our column, and we could just do a sorting. Now, if we do this, it is good, but not really what we need. Now, other clear way of doing that would be using ranks. So for example, if I do a ranks, and instead of doing a sort, I would use order, and then basically pass in my column. So I would say DF, and then I would use age. Now in this case, if I look at ranks, it shows me a vector of ranks with rank position of each element. Now if I do a df $age, it shows me the values, and if you look at the ranks, it will tell 21, or here the lowest value is your 28, and that's the lowest value, and that's why we see as rank as 1, and so on. We can look at the ranks. So what we can also do is we can just do a df and then basically use ranks, and we can just look at the result. So this shows data frame, which is a ordered data frame now based on ranks. Now if we would want to do it in a descending order, what we could also do is we could do a df and then use order, and within order I will basically pass my data frame. I will choose my column, and then I could say decreasing equals true, and I could do this, and here this could show me the value. So it says undefined column names. So what I would have to check is what is my data frame here. So we have age, and then what we would have to do is we would have to select a particular column. So let's do that, and here I have just selected the column, and then there is a comma missing that was showing an error. So now we can have the data ordered in a descending way. So there are dozens of packages such as dplyr, data table, which can help you manipulate, filter, merge, and sort your data frames. So this is in brief about the data frames, working with data frames, subsetting them, and also sorting the data in your data frames. Now, one more important type of object in your R is vector, and that really helps us in various ways. So let's see how we work on vectors here. So to create a vector, we can use the C function and pass in the values. Those will be the objects or elements within the vector. And then you can look at the value of the vector, or also at the class of it, which tells me the values are numeric. Now in case of vector, all the values have to be of the same type or belong to the same class, we can say. So here we are creating a vector, looking at the value of it, and then looking at the class, which says the values passed in here are character. Similarly, we can do it for numerics, that is true, false, and then look at the value of this, and this class is logical. Now what we can also do is we can print all the three vectors at once, and here we will use semicolon to separate two or more variables, and we can pull out the values of all the vectors which we see here. Now what happens if we pass in the values which belong to different classes, or you can say different data types? So within a vector, if you do that, there is something called as coercion which takes place, which will convert all the values into one type, and in this case it has converted everything into character. Similarly, we can pass in values wherein we can pass logical and numeric, and in this case it's not going to go for character, it is going to convert everything into numeric. Now if I had done this where I passed a character and numeric, and if you look at this, then it has converted everything into character. So character always takes a precedence if it is one of the values of vector, and you have other values which are not characters, then in that case coercion will happen. There is one more way of creating a vector, and that is by providing a range to your C function. So we can do that here, wherein I set C1:20, and then basically look at the value of vector 7. So it shows me all the values starting from 1 till 20. However, there is one more way. You can use the sequence function to do the same thing. Now I could avoid the bracket, I could avoid the C function, and I can straight away pass a range, and that is also fine to create our vector starting from 1 ending at 25. So what if I want to create a vector with odd values between 1 to 20? Now in this case, I'm going to say how many values to skip or to jump. So I'm creating a variable called odd value. I'm using sequence function, and then to that I'm passing the beginning number, the ending number, and then the skip or the jump. And now if you look at the values, it shows me only the odd values. Well, we could have done the same thing to get even values, and that's not very complicated. So you can start from 2 and then you can do skip, wherein after 2 it basically gives you every second value. So we are looking at the even values, and this is how you can create a vector which is having odd or even values. Now, what if you want to create a vector with 10 odd values starting from 10? So you are basically giving a length. So here you can say from where you would want to start, what is your skip, and then the length of the vector, which tells me it gives me 10 odd values beginning from 20, or from 20 onwards, that is we take it from 21. Now, one of the requirements is always to name the values so that we can access the values either by indexing or by their name which have been passed to the value. So let's see that. So let's create a vector which is called temperature. So variable is temperature, pass in the values to this, look at the values of temperature. Now what we would want to do is we would want to assign these names to each value, which makes it more readable, more accessible. So I can use the names function, pass in my temperature as a vector to names function, and then assign the names to each value of temperature. Now if you look at temperature, it shows me the names which have been assigned. Well, we could have done it in a different way. We could have created a vector of names, something like this, and then what I could have done is I could have created one more vector such as temperature, and instead of assigning values, we could have assigned the vector to our existing vector. So if you do this, so you're assigning the names vector to the temperature one, and now look at the values, it still does the same thing. So this is where you are assigning names to every value of your existing vector. Now there is one more way, and that is using your sequence. So here I'm creating a sequence which starts with 100, ends at 2020 with a skip of 20 values, or every jump would be 20 values. So let's do that. Use your names function on price, and then what I'm going to do is I'm going to use my paste 0 option, which takes P and then 1 to 7 as the values. So we know paste 0 basically skips the space, and we are going to assign those values to as names to price. And now let's look at our price. So that basically gives me the names as we desire. So these are some smarter ways of assigning names to every element or every object within your vector. Now, how do we perform some basic operations? Let's have a look. So let's create a vector passing in the values, and then you can simply do an addition on two vectors where each element is getting added to other element of the vector. You can subtract two vectors, that is element to element subtraction, element to element multiplication or division, and you can basically perform operations on the vectors. Now, how do we use some inbuilt basic math functions? And that's pretty easy. This is my vector. Now let's do a sum which sums up all the elements. Let's find out a standard deviation for all the values. Let's find out the variance for all the values here. Let's do a product of vector values, find the maximum or find the minimum value. So these are some basic inbuilt math functions which sometimes are useful in our data science or data analysis kind of activities. Now, one more requirement might be comparing the vectors using comparison operators. And this is where I create a vector 1, create a vector 2, and let's find out the values in V1 which are smaller than V2 values, and that gives me the logicals as the response, that is false, true, and false. Similarly, you can do V1 greater than V2, or you can say where V1 values are not equal to V2, or equal to V2. So these are some simple comparison examples. Now I can create a different vector and then I can find out individually if the elements in the vector are lesser than 3 by just doing a V lesser than 3. So it compares each element with this. So you are actually using one scalar value to compare it with all the elements, and you can do that. It gives you the logicals. So you can also be doing slicing and indexing on vectors. And this is very much important when you're storing your data in vectors. How do you access them? So let's create a vector using sequence. Let's give it some names as we have seen in past. And let's look at our price one. So that tells me the name and the values. Now you can access the elements using indexing. So let's get the third element and it shows me 590. Remember, the indexing here starts with 1, unlike other programming languages like Python, where indexing starts with 0. Now I can also get the third and fourth value by doing a 3:4. I can also specify the vector and say 1, 4, and that shows me the first and the fourth position or second or sixth position. So this is one way where you are using indexing to access the elements. Similarly, I can give the names. Now that's where we see the benefit of giving names to every element. So I can use C function, pass in the name, and look at the value for that particular name, or selectively select different columns or different names. Or we can also use this square brackets wherein we pass the names. So sometimes it can also be useful to use logical positioning. That is, we would want to find out the logical position if the value exists, and we can do that, or using true and false and then look at the values. So there is one useful way where you can exclude a particular position. Might be that is an NA value, might be a value which you are not interested in, and that's where you will say -2, which will skip the P2 value, or -2 and -5, where we are skipping a P2 and P5, and we can exclude particular values from our vector. Now, how do we do a comparison operator on the values of vector? So you can just say price 1, and I would want all the values which are greater than 600, or you can assign this to a filter and then basically pass in the filter for your vector. So these are some simple basic operations which you can run using your R programming, where you would want to manipulate, where you would want to store some data and extract that data, use your different logical operators or other operators, and perform your basic easy computations. Now that we have seen some basic operations using R, let's look at some more operations when you're working with vectors, such as one of the common issues is handling the missing values. Now here we are assigning a vector to a variable order detail, and this one has a missing value. Now let's see how this is handled. And you see all the values in the vector are assigned. What you can also do is you can assign names, as we have seen earlier, by using the names function, and then look at the value of order detail. So you see the names, and these are your missing values which are also taken care. Now what we can also do is we can perform an operation on a particular vector which will be applied to all values of the vector. So for example, here I will just add a scalar value +5 to the elements in the vector, and that shows me number 5 has been added to each element or each object in the vector. Now, if you would want to work on two vectors, for example, to add two vectors, let's create a vector called new order, and then let's add it to order detail. Now, in this case, what we are doing is we have a vector which is from 5 to 10, and what we are doing is we are adding values to order detail. Now, our order detail earlier was 10, 20, 30, NA, 50, and 60. And what I have done is I have passed in a vector which is 5 and 10, and you're adding it to the elements. So 5 gets added to 10, and then your value 10 gets added to 20, and Then you have again 5, which is added to 30. Now you cannot add in anything to a missing value, so that remains as it is. Then you add again 5 to 50, and then 10 is added to 60. So in this way, you are adding two vectors which are not of same length, but you are adding these values. Now what I can also do is I can update the order by doing this. So I'm creating an update order. And now let's look at the value of update order. What does it show? So you are basically doing the same thing. So if you would want to work on a subset of vector, how do you do that? So here you are using some indexes. So I'm saying order detail, and this is my order detail. So let's take 1:2 and assign it to first two. So if we look at the value which is assigned to first two, we have just sliced and added a subset of vector to this one. And if I would want to take the length of order detail, it shows me the length here, which is 6 elements here, including the missing value also. What we can also do is we can do some more operations. So for example, from order detail, what I'm doing is I'm saying length minus 1 and then up to the length. So let's do this and let's see the result of this. So what we have done is we had our order detail which had these values, and what we have done is we have said length minus 1 colon length. So you have taken these two elements and you have assigned that to your v1. Similarly, we can do length minus 1 and 2 elements. So I can do this, and now let's look at the value of v2. So this shows me the value where you are taking length minus 1 and then you are taking it till the second position of the index element, which is 20. So you are getting in the values here. So you get your 50, NA, 30 and 20 because you started with length minus 2 and up till the second index position. Similarly, we can use the length and we can take it from this element, and let's look at the value of v3. So that shows me that I'm doing some slicing, or I'm getting subset of my vector. So similarly, you can also do this one. So v4, and let's do this, and then let's look at the value of v4. So it gives me the values based on our subsetting or slicing. Now you can extract all the values below 30, and this is where you are doing a comparison. So you will take your vector and then you would want to compare each value if it is less than 30, and you would want to take all the values here. So it gives me the logicals or the response for all the values which are lesser than 30. What we can do is we can also use the square brackets and do this. This will show me the actual values. Here we were just getting the logicals, but here we are getting the values. Now to omit NA value from the vector, we can use NA.omit, and this one will help me in getting rid of the NA values. Plus I'm also checking the values if they are less than 30, and then I am basically doing using this NA.omit. So you can do something like this. You can look at the values. What you can also do is you can find the order details that are multiples of 3, and here we would want to use modulus, and we would want to find out if the remainder is 0, then I'm getting the numbers which are divisible or multiples of 3. So let's do this, and it gives me again the logical values of all the values which are divisible by 3, giving us a remainder of 0. Or if you would want to look at the values, then you can say order detail, open up a square bracket, and then pass in your condition. Now we can then omit NA from this one, and then we can look at the values. So this is a simple way where you are subsetting a vector or extracting the values which you are interested in, which might be one of the requirements of your data wrangling or data manipulation or just data extraction. Now I can also use a sum function. Now if we do this, it returns NA because there is already a missing value and you cannot do a sum on the values. Now what I can do is I can do a na.rm to remove the na values. So I can do a sum on order detail where I intend to add up all the values. But what I also want to do is I want to remove the NA value. So I'm giving it a value as true. And then if I do it, it gives me the sum of all the values. So similarly, you can do a mean, you can do a maximum, you can find out the minimum value, standard deviation, or even square root. Now these are some simple operations what we are doing on vector where we are interested in extracting some specific values. Now let's look at matrix, which we have also discussed, and matrix is also one way where you can use the matrix function to create a matrix which is multidimensional. So for example, if I do this and if I look at the value of V, I get a matrix which starts with the value of 20, ends with 30, and at any point of time you can convert this to matrix. So first we created a vector, and now I'll create a matrix out of it, wherein I am seeing the row numbers, I'm seeing the column number, and I'm seeing the values in that particular column. So you have already done that. Now let's take it to the next level. So let's create a matrix wherein we are using the matrix function. We will say 0, 3, 3, and now let's look what it has done. So you have created a matrix which is of 3 columns and 3 rows, and by default the row number and column numbers have been assigned to them. We can also create a matrix by passing in values. So we can say 1 colon 9 and then give the dimensions, that is number of columns is 3, number of rows is 3. And if I look at the matrix, now I have passed in the values to my matrix. So sometimes you may want to arrange the data in a matrix for particular kind of calculations. You can also use n row and by row. So you can say how many number of rows you would want, and you would want to assign the data row wise. So when we are doing this, now if you notice the difference between the previous one where we just gave the values and we said 3 rows and 3 columns, so it was doing it column wise, so 1 2 3 4 5 6 7 8 9. But here we said by row is true, so it has arranged the values in a row wise fashion. So it goes 1 2 3 4 5 6 and 7 8 9. Similarly, I could have just done this by giving the dimension and selecting by row, and if I do this, it is still doing the same thing. Now what we can also do is we can create matrix using vectors. So here let's create a vector stock 1 and then stock 2. Now we would want to merge both the vectors. So you can always do a C function and then create a new vector that is stocks, which is a merged result of stock 1 and stock 2. And let's look at the result. So that's my stocks, that's a vector. And now what I would want to do is I would want to create a matrix using the stocks. So I'm giving it a name, that is stock.matrix. I'm using the matrix function wherein I will pass my vector. I will say by row. So I want the values to be arranged row wise, and I'm also selecting the number of rows. So if you look at this one, so the values which we had in our stock, which was all the values, have now been arranged row wise and in 2 rows. So it starts with 450, 51, 52, 45, and 68. That's my first row. And the rest 5 values are arranged in the second row. So one of the main requirements is instead of going for default column names and default row names, we can give specific names to our columns and rows to make more sense to the data. How do we do that? So we can basically say days. So this is a vector which we are creating. And then what we want to do is we want to create a new variable, which is stock 1 and stock 2. Now this is for my columns and this will be for my rows. Now how do we assign that? So we can say column names, and this is where I will say on my stock.matrix I will assign days, which has 5 values, and that will become my column names. And similarly, using row names function, I can basically assign row names to my matrix. So if I look at my matrix now, it shows me the column names and row names which we have assigned or which we have passed to our matrix. Now, there are different functions which are associated with the matrix, and let's look at some examples. So these are some simple basic examples. Now, if I say, let me find out the number of rows, and that gives me the number of rows or number of columns, or get a dimension, that is the number of rows and columns of your matrix. Now, we might be just interested in getting the row names or column names or even the dimension names, which basically will give me returns the row and column names. So in this way, you can use these simple functions which are associated with matrix to extract information about your matrix or data which has been transformed into matrix to pull out some information about that. One of the requirements which data scientist or data analyst might face is carrying out arithmetic operations on your matrix. Now what we can do is we can create a matrix which takes values 1 to 50. We want to arrange it by rows, and we will say number of rows is 5. So that's my values starting from 1. Now I can do a addition here by just doing a 5 plus mat1, and if you notice, number 5 as a scalar value has been added to every element of the matrix. Similarly, you can do a multiplication, you can do a division, you can basically return the quotient if you would want to do that, or go for exponential values. So you can perform simple arithmetic operations for every element of the matrix. And what if you want to have arithmetic operations done on multiple matrix? So let's create mat1 plus mat1, and we get a total where every element is added to every element. You can do a subtraction, you can do a multiplication, and you can get the values. So this might be also very useful when you're working on multi-dimensional data. You can also do some more operations on matrix, such as returns the sum for each column. Say you are doing a summation or at a row level, or you want to do a mean for every row, you can do that by using these simple functions. Now you can add rows and columns to a matrix using rbind and cbind functions. So rbind is for row bind and cbind is for column bind. But for that, we have to first create a vector. So let me create a vector of same length, which will then be added to every or added as a row to my existing matrix. Now my matrix has 5 columns. So let's create a vector with 5 elements, and then I can basically add this as a row to my existing matrix by doing this. And now if I look at my values, I will see the new values as the third row. And if you also see, the variable name becomes the row name, and we have added a row to our matrix. Now similarly, I can find out row means, that is we have seen earlier, by calculating the mean or average. So I can do that, and I can find out the value of average. Now what I can do is I have got the average for every column, and what we can do is we can basically do a column bind by using a cbind function. And I will say I'm going to take the total stock, which has 3 rows, and then get the average. And now let's look at the total stock, which shows me the average value, which is the new column which has been added to the matrix. So these are some simple, very simple operations which you can do, but that gives you good insight in what can be done at a matrix level where your data is arranged in multi dimensions. Now, how do we do a selection and indexing in matrix? So in vectors, we were using either names, or we were using positions, or we were using indexing. Now here, let's create a matrix called student, and we are using the matrix function. But within the matrix function, we are using the C function to create a vector, which will pass in all the values, which also has NA values if you closely notice. We will split these values into number of rows is 4. So that means the values, the number of values in this vector should be a multiple of 4. I'm saying columns is 4, and I would want to arrange this data row wise. So I've done that. And if you would want to get the dimensions out of this, so I can do a dim names. So what I'm doing here is on my student, I'm assigning a list which will basically have these names which are basically assigned. And now if you look at your student, it basically shows me the values which were first applied to the row names, that is John, Matthew, Sam, and Alice. And then you have one more vector which goes as the column names for the values. So you have not only created a matrix by using a vector, by defining your dimensions, that is number of rows and columns, you have arranged the data in a row order. And what you have also done is using a list function, you have passed in the values which will be applied as row names and column names to your matrix. Now, how do we extract particular columns here? So we can take our matrix and we can just say comma 1, and that basically gives me the values for John, Matthew, Sam, and Alice. And what we are looking at is the first column. Now I can also say from first column onwards, I would want to look at how many columns. So I can do this. And now here I'm selecting first and second column. I can also be using a vector function here, and that also does the same thing where I'm saying 1, 3, and I'm getting the values from first and second column. So third is not included here. Now, if you would want to do row wise, then you have to give the row position first. So if I do a student 1, that gives me the row values. And this is giving me values for my student, which we are seeing here. So for John, we have 20, 30, NA, and 70. And that's what we get here when you do a row wise operation. You can also do a row wise and how many rows do you want. You can use the vector function to do that. You can also select or slice out a value where you are getting an intersection of row 2 and column 2, and then you can also start from a particular position and then onwards get your rows. So these are different ways in which you are slicing the values from your matrix by columns or by rows. So at this point of time, let me just type in student here and let's look at the value of student. And then here we are interested in 3 colon 4 and then 2 colon 3. So what does that give me? So you are looking at third to fourth row. So you're looking at Sam and Alice, and then you are looking at columns 2 and 3. So that basically gives you your 26, 32, 24, and 8. So first is you're giving your row positions or how many rows you want, and then you're giving your column. So similarly, you can do this. You can say from row number 2 to 4, and then column wise, you can say 1 to 3. So if we do this, so this tells me 2 columns, which is first and second, and it shows me rows, which is from second to fourth. So in this way, we can extract data based on rows and columns. Now, if we would be interested in finding out a specific value, so for example, if I again bring up student, this is my student, and what I would be interested in is getting the value of John and for specific subjects. So might be we are looking for 2 colon 3. Now if I do this, it shows me for John, and what we are interested in is 2 colon 3. So that gives me the value for chemistry and biology. So you are giving the columns. So row wise, you have already specified the name, and that basically selects the particular row. I could have given a number and chosen which row or which rows we would want to pull out the values. Now, if I would want to find out the value for John and Sam, now in that case, I could use indexing or positioning, but that has to be continuous. But here you're talking about John and Sam, which has Matthew in between. So we will basically we will get the values for John and Sam, and then we will look at the value 4. Now that is basically giving me the values in the fourth column, which is 70 and 75. Similarly, if you go further, you can look at maths and bio score of Sam and Alice. So you will give your row names, that is Sam and Alice, and then you would want the values for maths and bio. So that is basically your third and fourth column, and we can do that by looking at the values. How do you find out an average? Well, that's pretty simple. You can use the mean function on student. You will select your row name, that is John. You also want to get rid of NA values, otherwise that will give a problem. So you get rid of that by saying NA.rm equals true, and then you get the average score of John. Now, how do I do further computation? That is, if I want to find out the average and total score of all students. So in this case, I can apply, or I can use an apply function. Here, I'm saying I'm working on student, and we would want to give the row number, that is 1, and we want to also give the column. So I want to find out mean. I want to remove or get rid of the NA values. And now if I look at help apply, it tells me how does the apply function works over array margins. So I will do an apply function on student, where I would want to select the first row. I would say I want the sum, and I want to get rid of the NA values. So this gives me the sum for each student. And here we are getting a mean value, which was for each student. So what we are doing here is, for example, let's look at student again, just so that we avoid confusion. So we have student, and then we have physics, chemistry, bio, maths, and I have said row 1. So basically what we want is, for John, we want the total. And what we can do here is we can say 20 plus 30, avoiding NA, and then 70, that gives me 120. Then you look at Matthew. So this is again doing a totaling. There is no NA value, and you look at the value, right? So when we have chosen apply function, we have worked on student. Now here we are interested in the values, that is sum of all the values for this particular row. I'm saying take care of NA and then give me a sum. Similarly, you did a mean, and that was giving you a mean for each student. So these are some simple operations. Now what we can also do is we can basically create a vector called passing score. And what we would want to do is we want to get the values, or find in how many subjects Alice has passed. How do we do that? We will have to compare Alice score, which should be greater than or equal to the passing score. So what we can do is we can create a variable here, pass. Now I'm saying student, I would be interested in the values for Alice. So I've mentioned that row name here. I'm then comparing it with passing score, which we have created here, and that will give me the values wherever Alice has passed in a particular subject. Now I can obviously get rid of the NA values and then look at this, which basically tells me there was one subject in which Alice passed and rest were either false or NA. Now same thing we can do for Sam. So Sam is here, and what we want to do is we want to look at the values here. So we will say let's do the same thing for Sam and find out the comparison with passing score and get rid of NA values. So you are basically extracting values. So these are some easier operations and usage of functions on your matrices, which are filled in with values at row level and column level, and then you can apply one of these functions or multiple functions to basically extract value, which makes more meaning. So that's with your matrix. Now let's also look at data frames. Now data frames, as we know, is basically data which has been ordered in rows and columns, wherein we can assign row names, we can assign column names, we can do some operations on data frames. So let's look at example. So if I do a data here. So that gets me some sample data sets or functions what we have here. So let's do, once we have our data here, so it says use data package, and then you can get list all the data sets in available packages, and you can basically look at all the R data sets which we are seeing here. It has opened up. So I would be interested in getting the air passengers data, so I'm going to pass that in the data function. And then if I do a head to see the initial data from air passengers, it shows me the values what we have. Similarly, we can do that on iris data set and look at the head values. I can do a view to look at specific values in a tabular format if that makes more meaning and that makes it easy for analysis. Now I can do a view on state X77, and that basically shows me the population and income and all this for different US states. So these are some different data sets what we have. You can do a view on them to basically understand the data or look in a more readable format. You can just do a tail to get some end data. So head and tail functions just give you the top 6 entries, or basically your entries from that particular data set. Now the question is, how do we work on this data? So I can get a statistical summary. So I have the iris data set which we had here. So if I do a head, it shows me iris data set. This is a popular data set which shows the petal length, sepal length of particular flowers and the species, what is the length, what is the width, and what species does that flower belongs to. Okay, now here we can get a summary, that is statistical summary of a data set, which gives me mean, first quartile, median, mean, third quartile, and maximum values. It basically shows you the count of the entries for each species what we have under the species column. Now what I can do is I can check the structure of this data set using str. I can create a data frame now of this data using the data.frame function. So for that we need to also have, say for example, if we would want to create a data frame, let's see how do we do that. So first we create a vector of days, we can create a vector of temperatures and rain, and then we want to create a data frame out of this. So I use the data.frame option. I pass in my days, temp, and rain as the vectors. And now if you look at the data frame, you basically see that I have my days, my temp, and rain. So those were the variables, those were the vector names, and those have become the column names. Row names are auto assigned, and basically we are seeing the values which have been passed in my data frame. Now I can do a summary on this to basically look at what is the length or how many values we have in data frame, what is the class of elements, so that is character. You are looking at your values or summary which gives you mean, first quartile, median, mean, and so on. And then it also shows you the complete data on rain. What is the mode here, how many false or how many true values we have. You can also look at the structure of this data frame by doing a str, which gives me how many objects we have, how many variables we have, what are the different variables, so that is days, temperature, and rain, and the values for those. For days, if you notice, it is of the type character, temperature is numeric, rain is logical. Now how do we do data frame indexing? So like your matrix, which basically has rows and columns and in multi dimensions, similarly in data frames also you have indexing. So you can do a data frame. So I could just extract the first row by doing this, and that basically gives me the value. So you can always compare it by just typing a df. So that's my data frame. And now let's look at the values. Extract the first row, and that shows me Monday 25.6, rain value is true. Now I can also do it column wise. So for example, I could do it in this way. So here what I'm doing is I'm doing extracting the second row from this one. So it tells me 25.6, 30.1, 40.0, 37.3. So you have extracted the values for the column, right? So I would not say extract the second row, you would say extract the second column. Okay, so this one should be second column. Yeah. Now selecting using column names, so that's the easiest way to extract the values for a particular column. So I can just do this. Instead of giving the position of the column or the column number, I'll give the column name, and that gives me all the values of temperature. And if I do this where I'm saying 2:4 and then I'm giving the columns, so it gets me the second, third and fourth rows for day and temperature. And we are looking at the values. So you have given your row names and then you have selected your columns. You can also do a $sign if you would want all the values of a particular column. So I can just do a df $days or df $rain, and it shows me the values from my data frame. Now, one more way of doing that is using your bracket notation to return a data frame format of same information. So if you want the resultant data in a data frame format, you can just do a df rain or df temperature, and that is basically giving a data frame. So if I had assigned this to a value, and if I had looked at the type of this, that would be data frame. Now, one of the things which we also require is filtering data frames using a subset function. So that is subsetting the information from a data frame. So we know we have our data frame. Let's look at our data frame again. So that just reminds of what data values we have. And here, let's get a subset out of it using the subset function. So I'm passing in my data frame. I am saying I would be interested in the rain column. So I'm giving subset rain column, and wherever the values are true. So returns all the columns where it has rained. Similarly, I can do a subsetting by giving a value for temperature wherever the value is greater than 25, and that shows me the value. So this is where you are filtering the data in data frames using a subset function to which you have to provide a column name and then giving a condition. Now, one more important thing which might be required is sorting your data frame using order function. So I can create a variable by name sorted.temp. I want to do a ordering of data frame, and here I'm doing a ordering based on temp. And now if I look at the value, or I can create this in an ascending order. So let's look at the values. And now if I look at my data frame, it just gives me the order or the ranking for the particular values. So we have discussed this in other section also. So what I can do is I can return all the columns with temperature sorted in a descending order. So right now what we were seeing was we were seeing in an ascending order, but what we can do is we can do that in a descending order. So here I'm creating a variable descending.temp. I'm doing a ordering, but when I'm doing a ordering, I'm using the minus symbol. And this one, if you would look at in the form of a data frame, it shows me the values which are ordered in a descending order based on the temperature column. Now, another way of sorting is by using a particular column. So what I can do is I can sort, I can do a order, and then I can choose the column based on which I would want to order it. And then if you would want to get the values of this, so it tells me the values have been ordered based on temp. So this can be very useful when you would want to sort the data or order it in a particular way to basically understand your data or to make more meaning out of it, right? Similarly, one more requirement might be merging your data frames. So here I'm creating a data frame. So I'm saying authors and I'm using data.frame function. And what we are doing is instead of creating three vectors, I am basically doing that within my data frame function. So let's do that. And now what we can do is at this point of time, I can check what my authors look like. So this is my authors. Now here, if you see, we have the vector Turkey, Venables, Tierney, Ripley, and McNeil. So that becomes my first column, which is surname. Then you have your nationality, and then you have deceased, where you have also repeated the values 4 times, right? So that's something new which you might be seeing. So you are creating a vector where you are passing in a value, and for other set of values you are basically using a repetitive function. Now similarly, we can create a data frame called books, and this one is where I am having name column, title, and then I have other dot author, and you are passing in the values. So at this point of time, if you would want to look at your books, it would look something like this. So you have given a name. Now just closely look at the data frame function. So here you are using the names, you have the titles, whatever values you are passed in. Always remember, when you have multiple vectors, they are ending with a comma, right? So do not forget that. And then you have other dot author, so that's the name of the column, and you are passing in the values, where you have also passed some NA values. And at this point of time, you can look at authors. This is your books, and our intention will be to merge these data frames. So that's what we would want to do. Might be we are interested in getting the data together. So what I'm doing here is I'm saying M1. Now I want to use the merge function. I pass in my data frames, that is authors and books. So if we closely look at authors, it has 3 columns and 5 rows, and here you have 3 columns and we have 7 rows. So we would want to do a merge. So we'll say authors books, and we will say by dot x. So this is where I'm choosing which is the column based on which I would want to merge. So I have by dot x, which is surname, and by dot y, which is name. So we would want to merge the data where we are giving a condition based on values in surname and name. So you see there is Turkey here, there is Turkey here, we have Venables, we have Tierney, we have this one, we have Ripley, which we have here multiple entries, and then you have McNeil. Now we don't have R core, which is there in your author. So let's see what happens when we do a merging here. Okay, and now we see the result of this merge, where it has taken all the values from both the data frames. So you have surname, nationality, deceased, you get the title, you get the other dot author, which you are getting in from your books, and the name column is avoided, right? Because we are doing the merging based on surname, and but y dot name is name, so we don't see the name column. But what we are seeing here is the values which have been merged, and then you can compare. So for example, let's do a random check. So if I look at McNeil, that's the surname, or here it was name. So you have McNeil, you have a nationality which comes from the first data frame, deceased from the first data frame, then you have your interactive data analysis, and then you look at title.author. What you don't look at in the merge is this R core, because this does not have any value in your author's data frame. So you can do a merging of your data frames using the merge function. So please try it out, and you can create different data frames and try to use this. Similarly, you can manipulate a data frame. So for example, here we are creating one more data frame called sales report, which is data.frame. You are giving an ID, product has some values, unit price is where you are getting the values as integer and quantity as integer. So now if I look at my sales report, this is the values which I have. Let's spend a couple of seconds to look at this value. So ID value is 101 to 1010. Product is A, B, so that is automatically assigned. Unit price is starting where you say 101, 140, 184, right? So we are using a as dot integer, we are converting it into integer, and basically we are assigning these values here for your unit price. And similarly for quantity, we are assigning the values by doing a as dot integer and then just doing a run if. Now once we have done that, we have created a data frame. Now, how do you transpose? What do you mean by transpose? So transpose is when you are changing your accesses. So if I do a transpose on sales report, and if I want to do a view, so you will see the positions which have changed. So you have all these values. So my row names or row whatever values become the column headings, and basically your column headings becomes your row names. So that is what you're achieving by doing a transpose. You can do a head to look at some initial values. You can do a sorting of this data frame by using the order function, and you can choose the column and also the order if you would want to have it in ascending or descending, or basically increasing or decreasing values. You can also choose a particular column, like we are choosing product as a column, and I would want to take the values of sales report in a descending order, that is unit price, and we can just do ordering of data frames or sorting the values in data frame. So this is pretty easy. Please spend some time in practicing these things, taking these examples, and you will learn more about these functions. You can always try creating an example at your end, and you can try to look into these. Now, what about subsetting the data frame? So when you are saying subsetting the data frame, let's do a subset function like what we used earlier. I will say subset.product A. I'm using the subset function, and here I will get the subset based on the product value being A. Let's look at this, and this shows me only the values where product value matches A. Now extract the rows for which product is A, and unit price is 150. So you are still doing a subsetting, you are still passing your data frame. Here you will give the product is A, which will tell basically the values for product, and unit price greater than 50. So you're giving some conditions and look at the values. Now, if you're only interested in particular columns, so if I say only the first and the fourth column product is A and unit price is 150. So you have to still use your subset function, pass in your data frame, product will be given as A, and unit price should be greater than 150. But what I'm interested in is the values from the first and the fourth column. And now if you see, it shows me the values for my fourth column. What we can also do is we can create two subsets. So set A from data frame, where we take the product as being A, other one is being B, and then we can look at the values. So this is just A, this is just B, and what we can do is we can combine them or we can merge them using column bind. So when I say column bind and I'm saying set A, set B, so it is basically going to stack the data frames column wise, and if you do R bind, it is going to stack the data frames row wise. So we can either use column or we can do a row wise. So this is in one way where you can merge. The previous example where we saw merging was based on a particular condition which is met based on some columns which might have similar values, right? And this is where you are straight away merging the data frame using column bind and C bind. So if you compare this with the other merge operation, what we saw here, this was where you are comparing the values of first data frame and second data frame and then merging. But here we have just used column bind and row bind, so we are not merging on a particular condition, we are just stacking them either column wise or row wise. Now what we can also look at is doing some aggregate operations. This is going deeper into data frames. So when you use the aggregate function, you are passing in your data frame, you are choosing the quantity column, and then you are basically using the list function. So list function is going to work on your data frame on the product column. So product column for your sales report. So at this point of time, let's look at sales report. And let's look at the value here. So this is my sales report. And what we want to do is we want to aggregate the values on quantity column. But for that, I will say, I will just take the product columns and I will get a sum wherein I'm ignoring the NA values. Let's look at this, and that gives me an aggregation value. So remember, aggregate function is doing a summing up. Now here we are doing a summing up on your product, that is sales report product column is what we have. So you are kind of grouping by based on product. So we have two products here, A and B. Now what we also want to do is we want to take the quantity column. So that's why we have given that first. And what we are doing is we are doing a summing up. So we are summing up all the values for A and all the values for B. And we are seeing that here, if there are any NA values, we are ignoring it. So these are some basic operations on data frames or matrices, subsetting them, extracting useful information, using some inbuilt functions to do transformation or computation and extracting some values. Now, similarly, we can also work on lists. Now that we have looked at data frames, matrices, vectors, let's also look at one more structure and how we work in R when we have to work on lists. So list is basically a structure here, and what we are doing is we are creating a list by using the list function. And here I am passing in three vectors you see here. Now C function is being used. Now in vector we know that all the elements are of the same type. Now let's create a list wherein we see three vectors which are of three different types or objects of three different types. So let's create this list. And now let's look at our list. So it basically has elements wherein you have values of different types. We can create a different list which can also have sequence elements, that is 1 to 10, a matrix which is of 3 dimensions, and then also passing a list. So this is also one way of creating a list. Let's look at list 2. And if we look at the values here, list 2 basically has a vector which has values 1 to 10. It has a matrix of 3 into 3. It has a list which has values A having 10 and B having 20. So this is how you can create a list which can have objects of different types. So we can also use recursive variable, a variable that can store value of its own type. So for that, you have to use a recursive function, something like this. So I'm saying is recursive and then do it on your list, and we can check if the list basically has a variable that can store values of its own type. Now, one of the main requirements when you're working with lists is indexing. So I have created a list, and here I can access these elements by using an index. So if I do this, this shows me the matrix. What I could have also done is using the dollar symbol and then choosing particular element of the list by doing a mat, which is the name given to our matrix, or by choosing a name that is vector. So you can access the elements using indexing or dollar notation or giving the name of a particular element. Now I can also work on list and I can get the third element's second value. So we can do that, and that shows me 20, or you could have done by giving the value 3, that is the third element, and within that you are looking for second element. So I can get the length of the list, I can get the class of the list, which shows me it is type list. And what I can also do is I can convert vectors into list. So here we are creating a variable price, which is being assigned a vector which has 10, 20, and 30. And now what I want to do is I would want to convert this vector into list. And for that, I'm using the list function. So I am creating a variable called price list, and then I'm saying as dot list. So that's going to convert my vector into list. And now let's look at price list, which shows me a list, or you can look at price, which is a vector. So that's when you're converting your vector into list. Now, how do you convert your list into vector? And that also can be done by doing a unlist function. So I can basically work on price list wherein we converted vector to list, and I can just do a unlist on that, which will convert my list into a vector looking at the values of the vector. Now sometimes we may want to get the dimensions. So we can use the dimension function to convert the vectors to a matrix so that it can have multiple dimensions. So here we create a vector which has 4 values, and then I'm going to give a dimension to this so that it is converted from vector into matrix by giving dimensions 2, 2. And now if you look at price 1, it has basically changed into rows and columns of 2 into 2 dimensions. So these are some simple examples of working with list. Now, when you talk about basic data type functions, we have seen how you use the assignment operator, how you get the data type of a particular variable or the class to which it belongs. I can assign different values such as 10.5. So the previous one was showing me the value numeric, and now what we would want to do is we want to assign a value 10.5. Look at the class of it. It says numeric. Type of it shows double. So by default, it belongs to the double class. Now I can check if the values in N1 are numeric, and that shows me true. And similarly for N2, and that shows me 2. So you're using the numeric function, which returns true if the given value is numeric. Similarly, we can have integer assigned to a particular variable, and for that either I can do as dot integer or I can assign a value with capital L. So I can do this and look at the value of I1, similarly I2, and look at the values. And if I would want to check if that is an integer, let's look at the values of I2, which was an integer, I1, which was an integer, and I3, which is an integer. So here we have assigned integer values to a particular variable. Now all integers are numeric, but all numerics are not integers. So let's check that. So if I do a is numeric on I1, which was assigned as dot integer 10, that shows me true. If I say is dot integer on I1, so was that an integer? And if I look at the value, it shows me true. Now let's look at the character values. So if we say C1, C2, and look at the class of this, it shows me it is of character type. Similarly on C2, and you can always validate that by using the character function. You can also use some inbuilt functions such as converting to an uppercase or getting a substring from the starting till the position what you would want the elements. I can do a paste function, which basically will give me the data combined, or you can say concatenated. You can also use a paste 0, which we know will get rid of the space and it just concatenates them without a space. I can also use a specific separator, which we have seen examples, and we can do that. And what we can also do is we can replace set of characters. So here I'm saying substitute, and then if I look at the values, it has basically replaced Rob with Senna. And let's look at the length of it or number of characters in this. So these are some basic operations what you're doing on matrices, on your data frames, on your lists, and also on your variables, where either you are assigning them values of a particular type or you are changing the data types. You can also go for coercion. In case of vectors, we have seen that, where if you are passing in values of different types, that's coerced into same types. So later we can learn more on functions and flow control and how that is handled in R. Let's learn how R can be used to take care of flow control. That is, if I would want to have a if else condition, and if what I would want to compute, or if I would want to check some values, how R can be used. So here, if statement consists of a Boolean expression which is followed by one or more statements. So we can just say if, we can pass in a Boolean expression where we would want to compare particular value or we would want to check a particular value, and then whatever is passed in the statement will get executed. So what we can do is here we can use assignment operator. I can pass a value to X. Now we can always do a type of and that can tell me that x is basically an integer. And now I can use my if, where I can say is dot, and then I can choose integer, and I would want to check the value of x. If that is an integer, then I will just use brackets and I'll pass a statement here. So let me say print, and let's say x is an integer, and we can execute this, and this tells me that the boolean value is true. Now if, for example, we would have done something else, or say for example, instead of integer, if I had used let's say character for that matter, and we can check the value and we can do this. So here we will check the values, and it says there is an error with the bracket, and let's check this one. So if x, because we missed a bracket here, so let's do that one and then try this, and it doesn't show me any result. So how could we handle something like this if the boolean expression does not match to true? And in that case, we can always go for else statement. So we can check for a value. So if the boolean expression is true, statement will be executed, and if it is false, then next statement will be executed. So we could have done the same thing here, where I said print x is an integer, which we know is not true. And what I could do is I can here, after this one, say else, and then I can open up one more bracket, and then I can say print, and I will say x is not a character, and now we know that x is not a character. So this is a simple way where you can use if else, and you can control the flow by passing in the conditions. Now that's when you're using if else statements. Now what about while loop? So that also can be useful when you're programming in R. So an else statement is executed when the condition in the if statement results to false. So that basically means what we can do here is, let's pass in a word or a set of words like this. For example, let's say v, and then we use c function to create a vector, for example, and then I can just say hello world. And if you look at v, you can look at the class of v, it's of characters. And if you look at type of v, it is having the objects or elements as character. Now what we can do is we can basically then say count, and let's assign this a value 2. Now what we would want to check is the count of elements in our v equals to 2. So what I can do is while my count is less than say 5. Now I'm saying I would want to do something while the count is less than 5. So we have already given a value to count as 2. And now what I can do is here I can open up a bracket, I can say print, and then pass the value of v. And then what we do is not only this, we will also increment the value of count, and we will say count plus 1. And here it gives me error, probably because we have missed a bracket. So let's see what we are missing out here. So let's just check this one again. So here it is. We have created v, which has 2 elements of the type character. And then what we do is we assign count a value of 2. And we would want to check while the count value is less than 5, we would want to print the value of v. So what we are doing here is we are saying while, then you pass in an expression which will check the value of count. We do a print, and then we increment the value of count. Now this is a simple example where you are using while to basically test an expression, and while that expression is true, you would be doing something whatever is passed within your brackets. Now we could also be going for loop. Now for loop is basically used to iterate over a list of elements or a range of numbers. So for example, if I have a vector like fruit which has some values, I could just say for I in fruit I would want to print something. So let's try this also as an example to test our for loop. Now we can just say names, and we can basically then assign values to this. So let's say VJ, AJ, DJ, and let's say SJ, and let's create this. Let's look at the value of names. Now what I can do is I can use a for loop, and I can say for I in my names. So I will say for I in names. Now what do you want to do? So open up your brackets here, and then we would want to say print I, and then basically close the bracket. So you see, for every element in this vector, it is basically going to print the name one by one. So you're iterating through a set of objects by using a for loop. Now this is how we can work on for loop. So if else, while, and for loop can be very useful when you would want to iterate, or when you would want to check the value of an expression, or when you would want to loop and do a particular task. It's always good to understand how you manage flow control in R. That is, either when you're working with your for loops, your while loops, also understanding how you can use your logical operators for working with your data in R. So let's look at some examples and understand logical operations. So either you could be having and, or you could be doing a or where you're evaluating one condition, or you're using not. So these are your logical operations. Now here I can assign a value to x, and then I can check if my x value is less than 10, and it shows me false. So I have been checking the value of x. So let's see, is it greater than 10? And that's true. Now I can use logical operations here. So I can say and, so I'm saying, is my x value less than 20? And is my x value greater than 10? Now both these conditions are not true. So in this case, we get the result as false. But if I say x is greater than 20, which is true, and I am saying x is greater than 5, that's also true, and x is equal to 25. Now, whenever we are talking about and, we have to look at all the conditions have to be right. So let's look at this, and we get the value as true. But if I say x is greater than 10 or x is greater than 5, then one of the condition has to be true, which is true in our case. So we get the result as true. We can take a different example. We can say, is x less than 20, which is not true. But is x equals to 30, and that's also not true. So in this case, we get a result as false. Now we can straight away compare some numbers, and we can say, is 12 equals 3, and that's false. And if I say not, then that basically will give me the result as true. So these are some simple logical operations which help you when you're working with your data in R. Now we can create a data frame by using an inbuilt data set, empty cars. And let's look at our data frame. So that shows us the values with all the different car models and the different column names. So car models are the row names, and then you have other things like mileage and cylinder and so on, which are the specification for the data. Now what I can do is I can filter out values here using indexing. So I can say data frame. Now in that data frame, I would want to compare the value of mileage, which is greater than or equal to 30, and then I can end it with comma. So that gives me the value wherever the mileage is greater than 30. I can also do a subset on data frame where I can select a particular value. So we can be doing this, or we can be using square brackets. We can also do a dollar and compare the values. Now we will use our logical operations knowledge here. So we will work on data frame where I'm interested in the mileage, which is greater than 20, and I am looking at the column HP, horsepower, and that should be greater than 100. Remember, when we are doing a AND, both the conditions have to be met as true. And that shows me the result where you're looking at the mileage and you're looking at the horsepower column. Both of these are met, and that's why we get the result. So these are some simple examples of using your logical operations, either when you're working on a data frame. So same thing can be done on a matrix, same thing can be done on a list or a vector or individual values. Now let's also learn about flow control, that is how if else or else if is handled in R. So you can do a single condition check. So for example, I assign a value to hot, which is false, and I'm saying temperature is 50. Now what I would want to check is if the temperature value is greater than 60, which in our case will not be true, because temperature has been assigned 50. So is it greater than 60? No. So if I do this if condition, and I'm saying if the condition is true, then I would want to assign the value of hot to true. And now if you look at the value of hot, it is still false. Why? Because the condition which we passed for our if is not true. It has not been met. So whatever was passed within the statement has not been done. Now let's change the value of temperature as 100. And now if we do the same thing, we say, is my temperature greater than 60, which is right. So then whatever has passed in the bracket will be applied. So hot will be assigned new value. And now if you see, the hot value is set to true. So this is a simple single condition check what you're doing. Now certain times there can be multiple conditions to check, and that's where we use else. So in this case, we go for assigning a value to score, which is 63. So let's do that. And now let's say, is my score value greater than 80, which is not true. So whatever is passed in here, which is print, it's a good score, will not be done, but it will jump to else, and then whatever we have passed in else will be done. So it will say it's not a good score. So let's do this if, and it says it's not a good score. So this is a simple way of using if else, where you are checking two conditions, or you are checking the condition, but what if the condition is not met? Then your control is passed to your next statement. Now I can also do a else if. So I can say score is 63, and I can say, is my score greater than 80? That's my first condition. So it would print good score. But might be I would want to check something else. So I'll say else if, and I'll say, is my score greater than 60? Yeah. And is it less than 80? Remember the and, which has to evaluate and true for both the conditions. So I'll say print decent score. I can still keep on giving conditions here in else if. Is score less than 60 and score is greater than 33? That would not meet, so that will be ignored. And then you have else, which says print poor. So first it checks or evaluates for the condition which you have passed for if. If that doesn't work, then it goes to else if, and if anything in else if is met, then it's going to take that into consideration and it will not go for else. If and else if conditions are not met, then it goes to else, and we see decent score already printed here. Now that's a simple example of if, else, and if else if, wherein we are evaluating a condition, but probably we have multiple other things to check. Now, how do you work with while loops in R? That's very simple. So what we can do is we can assign a value to x, and now I will say while my x is less than 10. So I'm going to create a loop. So I have said my x has been assigned a value of 0, and that's fine. So this is going to be less than 10. But if we are going to just do this, then it will keep running and it will get into an infinite loop. So we'll see how we do that. So we'll say while x is less than 10, I would want to basically have the value of x. I would want to print x is still less than 10, adding 1 to x. And what we are doing is we are incrementing the value of x. Now, if you do not do this step, then it will get into an infinite loop because x will be always less than 10. So we are incrementing the value of x by 1, and then we are giving a condition. So if at any point of time x is equals to 10, I would want to say x is equal to 10, terminating the loop, and then basically my while loop ends. So we can do this. So let's say x is 0 and then do this while loop, and now you see it is at every step it is basically printing out the value of x. It is still less than 10, adding 1 to x, and it also gives you the value of x. So when we do a x is currently, and I print out the value of x, so it shows me 0. Next time you increment it, it becomes 1 and 2 and so on. So this is where you are using a while loop, where you are looping where based on a particular condition, and then you basically have, once the condition is met, you are able to complete the loop. Now let's look at, let me take this one here. We'll look into functions in a later stage. So let me take this function and let's get rid of this one. I would also want to talk on break statements and while loop. And once we are done with the flow control on while loops, then we can look at the functions aspect. Either we can look at how we control our functions or how we create built-in functions. So let's look at this one and let's continue with our while loop. So we just saw a simple while loop here, and what we also want to see is when you are working with your while loop, how do you break if a particular condition is met. So we saw a simple example of while loop, and that's fine, wherein we were printing out something, we were auto incrementing the value of x, we were also checking at one point of time within our while loop if the value of x was met. We would say we are terminating the loop and it comes out of that. Now, if that does not happen, then we continue doing it. How about a break statement? So break statement is when you would want to end the while loop if a particular condition is met. So for example, here I assign a value to x, which is 0. Now I want to evaluate this lesser than 5. So that means I will be auto incrementing the value of x. So I'll create my while loop. I'll give in a condition that x is less than 5. Now what I want to do is I want to use the cat function, which will print the value. So I'm saying x is currently, and I am printing out the value of x. Then I say print x is less than 5 because we have not yet incremented the value of x. We are adding 1 to x like what we saw in previous example. I am saying x is then incremented by 1, and here I'm saying if x reaches 5. So while we keep incrementing the values within the while loop, we'll see if x's value is 5, we will print it is equal to 5, and we can just do a break. Now if you do not use a break, you can still end the while loop, but break is basically to end this loop here based on condition which is met, and we can do this and then run this while loop. So you see here x was met as 5 and we just broke out of the loop. So that's your simple while loops what we are seeing. Similarly, we can work on for loops. So for loops can also be useful. So your conditionals, what we saw as if else or else if, your while loop is while a condition is not yet met, you keep looping and keep doing some actions. Now what you can do is you can also work on for loops. So here I'm creating a vector and then I am going to loop, that is I'm going to iterate through every element. So I'll say for, and when you're using for loops, you'll say for, and then you can give in anything, you can give in any value. I can say I can say x. So I'm just giving temporary variable in vector and then I'm printing it out. So this basically prints all the values one by one. So there is one more way to do it. You can say for and you can say I in, and I would want to take length of the vector. So 1, 2, the length of vector, that is till the last element is reached. I would want to print the vector elements using the value of I. So what is I here? It's the index position, and I can do it in this way. So if you are looping over a list, so I'm creating a list and it's very simple. So you can just do a for loop where you can say for I in list, I want to print the I, and that gives me the list elements. Or you say for I in, and you give from starting position, that is 1, till the length of list, and you would want to print every element. So here we can also use double brackets. So if you would want to loop through a matrix, so sometimes that might be required. So let's create a matrix which has 1 to 25 values around by row, and you look at your matrix, and now what you want to do is you want to iterate through a matrix. So you want to do a looping. So I'll say for I in matrix, I would want to print out the values, and that prints out all the values in matrix. Now what if I want to print the square and square roots of numbers between 1 to 25? So I can say for I, wherein the value starts with 1, ends with 25, and then within my for loop, I can basically give this condition where I'm saying, get me the square root, that is I into I, or get me a square root of I, and just print it out. So I'm saying message I is this one, square root is this, and my square is this, and square root is this. So if I look at this values here, now I am looking at all the values from 1 is to 25. I'm looking at the square of the values, and I'm looking at the square root. So what we did was we did a for. We passed in the elements by saying I in 1 to 25, and within the bracket I have said what do I want to do for every element. So either I've calculated a square, I've calculated a square root, and then I'm printing out when I'm using the message function, which takes the value which you are passing in, comma, the value of I, similarly square, and similarly square root. So these are some simple examples of understanding flow control in R, that is using your for loops, your while loops, and also your if else. Later, we will spend time in learning about functions, which could be either created by the user or built-in functions, and also factors in R. All the best. Happy learning. Take care.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.